Hello. In this lecture, I'm going to talk about obtaining quantitative data. Now, I'm going to start with some quite quick examples, and in each case, I'm going to ask you to think about what's the message in this example, what's the message about, and where does the data come from. So, for example, in this case, I've got this big poster by Oxfam International, and I would say that this message is about the fact that a large proportion of Africa's income is lost because of war. That's the message. Now, what does the message apply to? It's about all of Africa. So the message is about the loss of income because of war, but it's about all of Africa. Where does the data come from? From 4 countries. So the message is not about just the loss of money in those 4 countries because of war. It's about the loss of income in all the countries. Though it doesn't specifically say so. That's the impression it's given because it's Africa's missing billions. Right, another example. Fragile peace. Human security brief given out by the Human Security Centre in 2006. The first message here is most conflicts ended by negotiation. Most conflicts in the world ended by the 2 sides getting down and sitting together and talking rather than by one side beating the other. 3 times as many conflicts. What does this message apply to? Well, they're talking about the large majority of conflicts in the world. So all the conflicts in the world they're talking about. Where does the data come from? If you look into this, if you follow up the links at the bottom, you'll find that actually they've used a database of all recorded world conflicts. So in this case, the message is about negotiation rather than victory is how things end. That's the first message at the top. It's about all the conflicts in the world, and the data is from all conflicts in the world. Next one, from Colombia. Message here, well, the message is that negotiation is the best solution. Most Colombians think that negotiation is the best solution to war. Who's it apply to? Well, it's about the views of all Colombians, 45 million people. We might possibly finesse it and say it's about the views of all adult Colombians, whatever that is, 20-something million people. But where does the data come from? Is the data from all these 45 million Colombians? No, the data actually comes from here. And here, if you follow up the links, you can find out, well, these are the people they interviewed, 42 people here, 12 people here, 36 here, and so on and so on. 1,503 people they interviewed, and they were spread around like this. So virtually nobody from the Territorios Nacionales up here. A lot of people from Barambagosa, of course, and then in these regions. So the 1,500 people scattered across certain parts of the country, or located in these clusters actually, not scattered very far up in here. Actual data from 1,487 Colombians. They've lost a few. Right, here's some famous ones. These are from Millennium Development Goals. This is about gender differences in hourly wages. So the message is about the comparison of pay between genders in 12 countries. The message is about the wages of several 100 million people in all these countries here. But where does the data come from? Well, if you follow it up, it comes from a few thousand people in each of these countries that are interviewed. And from that, we get a message about several 100 million people. Another Millennium Development Goal example. Here we've got messages about people living on less than $1 or $2 a day. The solid line is what's actually been achieved. The dotted line is projection, if that carries on. And the other line is what they need to do to get to their target. So you can see that Sub-Saharan Africa not getting down as fast as it needs to get to the target. East Asia and Pacific ahead of target, and so on. Now, if we can ask about who this is, what the message is, well, the message is about progress towards the goals. Decline of poverty in the whole world. It's about the living standards of the whole world. These are all the regions in the world. 6.8 billion people. You should have wrote this a year ago. It's now 7 billion people. Where's the data from? They didn't ask me. No, they asked again a few thousand people in each country. So maybe a couple of 100,000 people total. And you've got a message about living standards of 6.8 billion people. Last, the very quick examples, I think. This is an example of gathering data on the web. It's a poll on the Friends of the Earth website. So I think it's a UK-based NGO, Green Campaigners. And the message here is that the majority of people will think that the negative effects of biofuels outweigh the positive. Okay, that's people's opinion. The message is about the views of who? Well, who do you think they're claiming the message is about? The views of the general public, or views of people that know what they're talking about, or have a green? But who's it about? Is it suggesting people in general? It doesn't really quite say there clearly. The actual data comes from 3,185 visitors to this site. And of course the next step is, well, if you were going to claim that this was about the views of the general public, how representative of the general public are the people that choose to go to this site? So you can start asking questions about the way that data is gathered and the effects that would have. Right, so much for zipping through those things. A couple of jargony words to make sure you get from this. Populations and samples. The population is all the values you're interested in. The message of the analysis is about the population. So the thing that your findings apply to, whatever that is the population. The sample, though, is the set of values you've actually based that on. You've actually got data on that. Could be the results of a survey. Could sometimes be the whole population, if you've got all the data, like in the example of all world conflicts. We have all world conflicts. The other extreme, the example of the Millennium Development Goals, population is the population of the world, samples a few thousand people here and there in different countries. Very often the sample just means those are numbers you've got in your computer. Some more quick examples now we have that jargon. Let's say you're interested in Zambian society and you want to know about intertribal marriage. Something I find very interesting is capital cities and towns are where people from different family networks, ethnic backgrounds, tribes, to use that word, meet up and have intermarriage. And then how does that change the different alliances and negotiations and life strategies of people that get involved in that? Fascinating. Anyway, this is going to be very long if I diverge like that all the time. Zambians living in Lusaka. So you want to know about this. You gather data on 40 mixed tribe households in the Kabwata suburb, which is one of the most mixed, slightly poor suburb. Now, point is, the population, that's what your message is going to be about. You're going to find something else about all these mixed tribe marriages. It's going to apply to, you hope, all the mixed tribe households in Lusaka. But there's more than 40 of them, so your sample is just the 40 you've talked to. From whatever these guys tell you, you're going to try and generalise about all this stuff. So that's the sample, that's the population. This time I'm not going to rabbit on about the next one. You want to know whether golden rice is going to work, giving more vitamin A than standard rice if you grow it in Bangladesh. So here's your technique. You can't check all the fields in Bangladesh, so you get 135 fields, that's your sample. Plant each field 50-50, so half the field you plant golden rice, half the field your standard or traditional rice. Then you see what you get. See what the yield is at the end, and test the yield for vitamins. So here the population is all rice fields in Bangladesh, the sample is the 135 fields. You're interested in some nice economics. Has debt forgiveness translated into rural health service improvements in Uganda? So is HIPIC working, the Highly Indebted Poor Countries Initiative and Poverty Reduction Strategy Papers? Is this having the desired effect in Uganda? Well, let's see. You want to know about all the rural health service improvements in Uganda. There's a few thousand rural clinics, but you just visit 82 rural clinics and get some data. So the population is all the rural clinics. You want to say something about all that rural health service. Your sample is those 82. Okay, let's whiz on again. Back to this. This looks like the same slide we had before, in that you gather data on 40 mixed tribe households in the suburb, samples of 40 households, but the population here is different. Let's say I wanted to say something about intertribal marriage just in this particular suburb of Lusaka. Then I could gather data still from the same 40 mixed tribe households in that suburb, but then when I publish my results, I announce my results, I say, well, this is telling me something about all mixed tribe houses in Kabwata, not necessarily in the whole of Lusaka. You can compare it, that's what it was previously, just Lusaka. Now, the message from this is that sometimes it's not quite clear what the population is. Are you going to just claim it's just this suburb, or you be more grandiose and say it tells you about just Lusaka? Or you could say, well, this tells me about mixed tribe households in all big cities in Africa. So the step from what your sample is to the population, that depends on how your ambition and how well you can justify that. How well you can justify essentially that the sample is in some sense representative of the population. But it's a flexible area. Right, we've zipped along to here. Now we'll think a bit more about the details of it. Well, sampling is this process then. When you've got a population you want to say something about, how are you going to decide which ones you actually talk to or get data from? So which 40 households do you interview? Simplest one is if every member of that population has got an equal chance of being in the sample before you start taking it, then that's known as simple random sampling. Here's an example then. I set up a computer to sample from a virtual village. I had the data in a spreadsheet. The village has got almost 2,000 households. Now, 2 NGO projects have tried in this simulation to assist 50% of the households to improve crop yields. And so out of the 2,000, about 1,000 have got some help. 1,000 households. Some of those 1,000 got improved seed varieties, high yielding varieties, drought resistant and so on. Others were given new tools. What we want to know is, have these schemes affected child nutrition? And what we do is, resources are limited. We decide we don't want to talk to all 2,000 for whatever reason. We select 30 households and do a survey. And that's, in this instance, what I've done is a random sample. And this is what the survey evidence showed me. It said that, well, mean child nutrition levels in kilocalories per day were, in the households that got nothing at all, that's the baseline, they got about 1,080 calories a day. Households receiving seeds was this, 1,284.5. Households receiving tools, 1,100.8. Conclusion from the survey is that households that were given seeds improved their child nutrition quite a lot compared to the ones that got nothing. And tools made a small difference. It's improved from 1,080 up to 1,100, to 20 extra kilocalories a day on average. So both projects seem to have worked. Child nutrition, a small amount. Okay, so that's pretty simple. But I'm kind of a bit worried. I'm worried that these results may not be reliable. In other words, remember the technical term reliable means if I went again tomorrow, will I get the same results? Could the random selection mean that luck could have played a part? After all, I just drew the names of those 30 out of a hat or on the computer just by random number generation. How was the selection made exactly? Was it different names or was it computer? Well, to see if I'm justified in being worried, what I could do is just imagine you could go back to that village again, do a fresh survey. That's what I did. Because it simulates, you could just do another survey. This time I found these things here that with no help, they got 1,107 calories a day, receiving seeds, 1,211, tools, 1,100. My conclusion this time, this survey, is that seeds improve child nutrition quite a lot. Tools make child nutrition a little bit worse. It could be that your mum and dad are looking at the shiny tools and showing them to the neighbours not getting on with it. So what's going on? Different results, what's happened? Well, I'm sure you find it easy to compare these numbers in your head. Myself, I prefer to put it in a table. These are the 2 surveys I've done. There's the zero effect. Here's the effect from seeds, and here's the effect from tools. And you can see in both cases seeds improve things and tools in one case make it better, in the other case made it worse. So also a certain amount of disagreement as to what happens if you do nothing. Okay. You could try doing a few more surveys, but first let's think why. This hopefully is going to resolve my uncertainties. Because I'm uncertain about this, I did a couple more surveys and I found that in all the cases it looks like seeds have improved things. In this case, again, tools have helped a lot. In this case, tools have made it worse. So it's uncertain as to whether that really has resolved things, because still it seems that sometimes tools make things better, sometimes tools make things worse. The problem is, of course, that in the real world you don't go and do lots of surveys, you just do one. So if I'd only done that one, I would have announced that seeds and tools both improve things, I would never have known any of this. So how can I tell whether or not I'd be justified to claim these differences just from one survey without doing lots and lots of them? I could keep on doing more and more surveys. I could aggregate all the survey results up together, or just take a larger survey, which is essentially the same thing. May all be feasible. An alternative is to try and seek some kind of certainty by saying, right, forget this sample nonsense, we'll just go to the population. I get all the population data, so my sample will be everybody. And in the statistics jargon, that's called doing a census. So a census is when you get values from everybody in the population that you're interested in. So let's suppose that we did that now. In the case here, I can do it because I've got all the data for the population in my virtual village. So that's what the census tells me. So these have been small surveys of 30 people each, drawn from this big population of, well, bigger population of 2,000. And now you can sort of see what, in this case, the truth, if you like, is. In households with no help, it was that. With seeds, it was that. So we can conclude seeds improve child nutrition quite a lot. Tools make no difference at all to child nutrition. Exactly the same. Comparing it with previous conclusions, this conclusion is the same as it's always been. This one's been changing backwards and forwards, but now we've got the whole census, we can see there's no difference. Question is, are these results the truth? Or could there be some reason why these results are not so great? And I'd suggest that, seeing as this is a recording, you could pause for a second and think to yourself, are these the results we should finally trust? Is this the truth? Or could there be a downside to this? Before we decide that, we'll have another bit of jargon. The figures based on the whole population are the population mean nutrition level. So back here, in this sample here, that first figure, that's the sample mean. And sometimes you see it in statistics, but it's written like that for survey 1. And some they might have a 1. That's the sample mean for survey 1. That's the sample mean for survey 2. In all cases for none. And then there's this, for seeds, there's another. This is the sample mean for seeds for survey 1, and so on. So these are the means for each sample. The mean for no intervention for seeds and for tools. Over here, though, this one is called the population mean. Mean for the whole population. And that's written with this Greek letter mu, which is the Greek for m, for mean. That's population mean. It's important to distinguish these because usually this is what you really want to know. Because remember that what you really want to talk about is the whole population. Even if you don't gather the census, and normally you don't, you just have this data from a sample, you're interested in knowing what this is because you want to know about the population. Remember, this is 2,000 people you're talking about, 2,000 households you're talking about here. Here, it's 30 households. Okay, 30 people, 30 households is important, but you're not interviewing 30 households just for the sake of talking about them. You want to say something about this. So the problem is always going to be when you just have a sample mean, what does that tell you about the population mean? How close is it? How close isn't it? So let's go back to this question here. Well, here's the jargon then, the population mean, sample mean. Now, the sample mean depends upon random selection process. Notice the sample mean is different each time you take a sample, whereas the population mean is the same. Population mean is not affected by luck. So does that not mean the census is the best way to tell the truth? Because there's no variation. Well, let's look at census in more detail. If you do a census, that means you have to collect data from the whole population. Then you can use relatively simple statistical techniques to just describe what you've got. You've got all the data. Remember, now you have all the data in your computer. Some simple stats will give you some descriptions of what the mean values are. Proportions, so you might have proportions of men, proportions of women, proportion of farmers, businessmen. Correlations, is there a correlation? That means a connection between education of women and fertility, or education of farmers and the productivity of farmers and so on. Simple stats will do that for you. And the advantages are, there's no need to worry about any luck of the draw, because you haven't just selected names out of a hat. You've talked to everybody. No random error is going to get into this at all. But disadvantages, and perhaps let's see if you might have come up with this. Time and expense. Instead of talking to 30 people in this example, talk to 2,000, a lot more. And possibly the accuracy of data. Because if I've got to talk to 30 people, I could be, maybe just as myself, I could talk to 30 households over 2 or 3 weeks, depending on how long you spend with each one, a week, 2 weeks, 3 weeks maybe. If I have to go to 2,000 households and interview them, that's going to take me a long, long time. If I had to pay someone, I have to pay them, it would be quite expensive. If I did pay somebody, I could probably afford to pay someone that was doing 30 households a lot more per household than I could pay someone that was doing 2,000 households. And not to be too neoliberal about it, but you can, if you pay someone a lot more money for something, you can hope that you get better quality out of it. If you're paying someone a few pence per household, they're going to rush around, not get such good data. So that there's a trade-off possibly between saving on time, between not worrying about the luck of draw by doing a census, so you get rid of this random error, but then you might introduce some accuracy problems. Survey, on the other hand, you just collect data from a sample, not the whole population. Now, the problem is, because you're only looking at a sample, and you're going to say something based on the sample that applies hopefully to the population, you need to use slightly more advanced statistical techniques. Advantages, though, are it's quicker and it's cheaper. Could be the accuracy of each bit of data you get to be better, because you can concentrate more resources on each household, because there are fewer to talk to. Disadvantages, the results will be influenced by the luck of selection process, whatever you do with surveys. As long as you haven't got a census, as long as you're just dealing with a sample instead of the population, there's always going to be some influence by just the luck of the people you happen to talk to. Right, now we need to think about, well, what errors can we get when we're doing some sampling, and what kinds of error are they? What are the sources? Where they come from, and what kinds of error are there? And here's some examples here. What I'd like to think about is, if you took these 4 examples, are there any obvious ways of putting them into pairs? Like, would this go with this, and this go with this, or this with this? How do you think you pair those together in ways that to show that they're similar? You might as well pause the recording for a second and think about how you would put those into pairs. First, we'll talk about sources of error. Well, one of them is called measurement error. That's when, for each household you go to, the recorded value doesn't correspond to the actual value for each individual. And let's remember here that an individual doesn't have to be something like a household. It could be, say, a tree. So you're measuring the diameter of a tree. It could be that you don't quite measure it correctly for each tree. Or if it is a person, you're talking to the person about the age, you don't get the age correctly. Sampling error is where, okay, maybe you measure things correctly, but the actual value of the individual selected don't represent the actual values of the individual in the population. Maybe the people you talk to just happen to be younger than usual, or richer than usual. Or the trees you happen to measure happen to be smaller than usual. So it's important to distinguish between these two things, conceptually quite different. Measurement error, on the other hand, measurement error, to set that first, can be caused by this kind of things. The tape measure is wrong, the weighing machine is wrong, question design is poor, as we'll see later on, memories of people, they can't quite remember things, influence of power relationships. If you're seen as quite a prestigious person, or they're afraid of answering something in front of you, or perhaps a woman in front of her husband, there's some problem like that which distorts the answer. Mistranslations, obviously, fear of authorities, desire for aid. They may exaggerate problems that you have, or because they think that your response after the survey is going to bring aid in. Or just, to put it in slang, blunders. You just write down the wrong number or make a spelling mistake. So those are measurement error sources. Sampling error Well, cause of that, this is when the values of the individuals are not representative. Well, there's two ways here: luck of the draw, or your technique's wrong. So it's not truly random. This you're always stuck with, even if you have a well-designed sampling method. You might still get some inaccuracy, but there are some ways you can design the technique wrong so the selection is not truly random. Now let's go back to these, and we'll think firstly about sources of error. Now how would you pair these? Pause it again if you haven't decided yet. How would you pair these so that you're talking about the same source of error? Okay, now I think that in this case and this case, the problem is here is that the people you're talking to don't really represent the people in the whole village. Here you're talking to people that are slightly better off and well fed. Here it's a question of whether or not here you're saying they do represent the people in the village. But still, when you select, if you randomly select from these people, you still won't get a perfect selection, but you'll the question of whether or not you get good answers here, accurate answers, will come down to whether or not you're lucky here in this case. Here it's not a question of luck, because the people around the village centre are on average are better off and well fed. Your sampling technique is wrong here. You shouldn't be just sampling people around the village centre. So here you're going to be led astray. Here you'll be led astray only, but it's not really your fault. So here in those first two, it's the sampling. Those are sampling errors. Whereas here, these are measurement errors. Measurement errors, because it's nothing to do with the people you talk to. It's the people you talk to, you've measured their heights wrong. People that are wary of criticising officials, they might not quite give you honest answers. So here, the data you record for each individual you talk to is wrong here. Here, it's a question of whether or not you're talking to the right individuals. So that's sources of error. That's how you pair it up with those. Now, moving on from sources of error, there's two kinds of error. The first one is random or systematic error. There's going to be some inaccuracy, but the inaccuracy is just as likely to be too low as too high. Or, and this one's more serious, bias or systematic error. That's when there's going to be some error, but it's more likely it'll be too high, or perhaps more likely it'll be too low. Now, each kind of error can go with each kind of measurement, each source of error. So you can get random error from sampling and from measurement, and you get systematic error from sampling and from measurements. What we're going to do here is go back to the examples and try, how would you pair these up thinking about the kind of error, random error or systematic error? So I'm going to pause it again and see what you think. Well, I think the way I would do it, so I say that people around the village centre tend to be better off and well fed, so they're going to, if I was measuring something to do with nutrition or income, I'm going to get on average higher than average answers from these people. So I'm going to be systematically led to overestimate the results there. Yeah? And the same with this one. People are wary of criticising officials. So when I'm asking them what they think of agricultural policy, or what they think of government, or what they think of security, or anything like this, they're not going to be critical. So their answers are going to be biased in one way. So in both these cases, sorry about the PowerPoint. In both these cases, here and here, we're talking about systematic. Error, which is bias, leads to bias. Whereas in this case, measuring heights carelessly, that means, well, it could be that I measure some are too high, some are too low. Here, because the drinkers and non-drinkers are equally likely to be in the village centre, when I pick people, I'm equally likely to get drinkers and non-drinkers. They're both, on average, they should both be fairly representative. If I don't get a fair balance, that's just going to be luck of the draw. So the error here is going to be random error. Still going to be some error, but it'll be just random error. In these cases, there'll be a systematic bias in one direction or the other, which is more serious. Now we continue to think of actual approaches to sampling, methods. In the remainder of the lecture, we're going to look at what methods can you use to reduce sampling error, and then what methods you can use to reduce measurement error. We begin with sampling error. In order to minimize sampling error, there's a number of different techniques you can use, and it's useful to know what kind of techniques or how they can be adapted for different situations. So first of all, we'll look at the major methods. We'll come back to measurement error later on. As I said, the simplest one is called simple random sampling. In that case, you just decide what's your sample size going to be, depending on how large that's going to be driven by cost and how many people you can interview. Though when you get more into the techniques of analysis, the technicalities of it, there are technical reasons for deciding sample size that we haven't got time to go into now. But you don't. Do you want to? If you speak to too few, then you lose accuracy. But largely, it's going to be driven by cost considerations in time and money. So when you've decided your sample size, then you've got to randomly select that number of individuals from the population. And randomly means that each individual must have an equal chance of selection for a simple random sample. Now there's many of the techniques for data analysis depend critically upon this. Either upon it having an equal chance or at least a known chance. You can correct as long as you know what the chance was. But for simple random chance sampling, they have to have an equal chance. If you do a sample and you don't know what the probability was, what the chance each person had was, then there's very little you can do in terms of generalizing from a sample to the population. So this is critical, that you need to know the probability for each person. And here we're assuming it's equal. The question is, though, how do we actually do number 2 to make sure that number 3 is true? How do you randomly select the people? Well, for a simple random sample, what you need is some kind of outline information for the population. And in its most basic form, it just means a list of all the people or all the trees or all the cows or wherever the population is. You need a list. That list is called the sample frame. As long as you have a whole list, then you can number the list, put all the numbers into a hat or more commonly into a computer, just randomly draw out however many numbers you need, and that gives you your sample. And you know, in the small print, it doesn't always cover the whole population. If it doesn't, then you've got to argue that it at least represents the whole population, which is another problem you give yourself. Okay, let's say you can't do that. If you haven't got a sample frame, which you often may not have a sample frame, if the local government don't keep records, or for instance, if you're talking about trees, not many forests have a list of all the trees, or a list of all the fish in an ocean. You need a different way. So you could use opportunity sampling. Here you decide on a sample size. And let's say you want a sample of 40. Then what you do is, in a simple clipboard in the marketplace, you wander around the market, stopping whoever will talk to you, and when you get to 40, you stop. So, people willing to stop and be questioned, fields you can get to by vehicle, so you want to get a sample of 20 fields measured, you drive round, once you've got to 20, you go back. Households' heads are in where you knock on doors. If someone's out, don't worry, you go on to the next household. When you've got your quota, then you stop and go home. That's opportunity sampling. Does every individual have an equal chance for inclusion? No, but is this a problem? Yeah. It is a problem if the ones that you sample differ systematically from those not sampled. In that case, you'll get some sort of bias. And of course, if you think about opportunity sampling, well, if people who stop to answer questions, if they've got particularly strong views, yeah, therefore, if they particularly feel strongly that they love the government or the new policy, or they hate it, they might be the ones that speak to you. So you won't get the average views of people. Again, if they've got time to stop and chat, maybe they've got lower incomes. Again, the opportunity cost of their time, as economists have put it, is lower. So they've got time to chat. Maybe retired people might be disproportionately represented. The busy person that's rushing around trying to get things done hasn't got time to speak to you, and so on. So opportunity sampling is not thought to be a good way of generating a sample which is representative. Again, fields near the road. Again, you get this again and again in writing on development. This is not very admirable that someone's come down the road from their hotel in their nice white four-wheel drive and just gone to the places that are convenient to get to. And you have to read well into the small print to find out that's what they've done. Now, populations, of course, are usually diverse. Now, very, very often, something you're trying to gather data on is related to other characteristics. For example, if you're talking about meat consumption, it might be different between men and women. It may well be different between religious groups. Or if you want to find out how well some new variety of maize is doing, that might differ between agroclimatic zones, or it might vary between what kind of irrigation is being used. So, if the distributions of these characteristics in your sample and in the population are not the same, then you're likely to get bias. What I mean by that is, let's take the maize example. You want to find out how's this maize doing in one region. What's the mean maize yield in one region of the developing country? Let's say that you know that in that area, 24% of all the fields are irrigated. Now, irrigation is going to be connected to maize yield. So if your sample's got 50% irrigated fields for some reason, then your figure for the mean maize yield is going to be too high because more fields in your sample are irrigated than in the general population. So you won't get a good picture of how well this maize is doing in the whole area. Yeah? So in all the fields, which is your population. Now, if you get a big enough sample, bias is less likely. I'll try and show that. I hope there's not too many numbers on this slide, but it's meant to be a simple example. Let's say we're going to the male and female example. Perhaps we're talking about meats, and let's say whether men and women eat the same. And you want a random sample of 1,000 adults. Now, for 1,000 adults, if it was perfectly balanced, you'd expect around about 500 each. Obviously, in some parts of India, where there's been proportions of genders are out of balance, it might not be exactly 500, but 1 or 2% either side. So you'd expect to get about 500 each, men and women. Now, let's say you just do a pure random sample of 1,000 adults. You can show mathematically that 99% of the time when you do a sample like that, you get between 42.6 and 57.4%. So you might not necessarily get exactly 50% men and women, but you get sort of close to 50%. Or, put it another way, you've got less than 0.5% a chance of getting more than 57% of men. So you've got a 95.5% chance it's going to be closer to 50 than that. So you're not going to go far away from a 50% sample. If you're a really big sample of 10,000, the equivalent there is you've got only a 5% chance of getting more than 52.3. So you're going to be within a couple of percent of 50. 99% of the time, you're going to be very close to 50. So the problem cures itself with a big enough sample. But let's say you can't afford to take that bigger sample. Let's say you only sample 50 adults. We can show that for this corresponding figure of 57.4, if you only sample 50 adults, you've got a 15% chance of getting over 57.4%. So a pretty good chance of getting quite a lot more men than women. To take it to extremes, if you take a microscopic sample of 3 adults, then the chances they're all going to be men, you figure that out? That should be 1 in 8. You've got a 1 in 8 chance that they'd all be men. So you're 100% men, so you're totally unbalanced. So the problem is that small samples, the random variation isn't effective. It won't give you a fair share. To make things worse, usually there's more than one characteristic. You might be interested in getting a balance of gender and religion and occupation and age. And the chances are that even if you take a reasonably large sample, at least one of those is going to, the chances are at least one of those is going to get out of kilter. So you won't have a good representation of all these factors here in your sample. So you need a very big sample or an improved method, which is what we can look at next. And that improved method is called stratified random sampling, where you don't use pure random sampling anymore. You use your sampling frame to make sure your proportions fit the population. So going back to this example, if you know that 24% of the fields are irrigated in the population, and you want a sample of 300, you don't choose the 300 randomly. What you do is work out what 24% of 300 is by doing that, 72. That means you know that you want 72 fields that are irrigated. And you take a random sample of 72 fields from all the irrigated ones. Then the rest of them, the other 76%, you take, which is 228, you take a random sample of 228 fields from all the non-irrigated ones. And that will give you a desired sample of exactly 300 fields that have got exactly 24% irrigated and exactly 76% not irrigated. Even though it's still a random sample, because each field will have the same chance of being chosen, but you make sure you get the right proportions. And that's called stratified, a stratified random sample. The non-random equivalence is quota sampling. In quota sampling, you can do a similar thing. If you know that in a certain area you've got 70% Muslim, 30% Christian, you need 200 people. Work out what 70% and 30% of those are. You need that many Muslims and Christians. This time it's similar to opportunity sampling, but you stop when you get to the quota for each group. So you just keep interviewing people. Once you've got 140 Muslims, you stop, and after then you'd only interview Christians. And similarly, if you get to the 60 Christians first, you stop, and then when you've got enough of each, then you stop altogether. It's better than opportunity sampling because at least you do get the right balance. But there's still a risk of bias because other unobserved characteristics, you can't tell whether or not they're being equalised by the random effects. So random stratified is better. The other problem you have that affects a lot of work in developments because of poor infrastructure is that often a population is spread over a wide geographical area. By definition, populations are spread over the whole area. Now, if you get a random selection from a sampling frame, you might end up doing a lot of travel. In other words, if you want to interview 2 people in one village and then 4 in another 80 kilometres away, that would be extremely time-consuming and expensive. So you wanted to do a random sample of all the people living in rural Uganda. If you did that, you'd end up, if you had a list of everybody that lives in rural Uganda, you selected people from that list of people to be in your sample, you'd end up with a few people in each village, and you'd spend years travelling from village to village across Uganda. Very costly and time consuming. It's better to introduce another stage of sampling. First you choose some villages, and then within those villages you choose all your individuals. And this is called multi-stage cluster sampling. So let's suppose you want to sample 300 people from these villages. So here's your whole population, everybody in these villages. You want to sample 300 people, but you can only travel to 2 of these villages. What you do is you choose 2 of the villages at random from the list, and then do a simple random sample of people in the 2 villages chosen. However, although conceptually this is simple, in actual fact it does introduce a problem. It's because if you choose your 2 villages at random, you can see that an individual that's in village B has got less chance of selection than an individual in village A. Because an individual in village B, because there's 1,200, for one person in this village to get selected, they've got to get through the hurdle first of random selection. If that was only a 1 in 7 chance, then they've only got a 1 in 1,200 chance of being selected. Whereas a person in village A, if their village is selected with a chance of 1 in 7, then they've got a 1 in 700 chance of being selected after that. So they've got more chance of being selected at the second stage. So because people in smaller villages have got more chance of being selected at the second stage, you have to give people in the bigger villages, give their village a bigger chance of being selected. So one solution to this is that in the first stage, you increase the chances of the larger villages. So you make the chance of selection for each village proportional to its population. Alternatively, if that's not done, then afterwards when you analyse your results, you give more weight to individuals from larger villages to compensate for the fact that they had a slightly smaller chance of being picked than they should have had. In a way, this is conceptually easier, but this is actually what's done sometimes in practice rather than that. But they come to the same thing. As an exercise, you might like to work out how you'd adjust the chances, if you like that kind of maths. Right, there is such a thing as stratified multi-stage cluster sampling. In actual fact, almost always the 2 methods are combined. So you can stratify at either level, so at the level of choosing the clusters or with individuals within the clusters. So you might want to ensure that, for instance, your clusters themselves are representative of coast areas, lowlands and highlands, some villages, some towns and some cities. And then within the clusters you want to check that the individuals are representative in terms of gender, religion and so on. So you can stratify using the stratified technique at the individual level or selecting the clusters. And the advantage of this is that if you're stratifying at the individual level only, then all you need is a sample frame for the chosen cluster. Instead of needing a sample frame for all the individuals in a country, you just need a sample frame, a list of individuals within your chosen clusters. So slightly less data requirements. Finally, we cover some other methods of sampling. Purposive or purposeful sampling, selecting sample according to judgment, more often used for qualitative research, honestly. You're selecting the most typical cases or perhaps the most interesting cases. So it's the judgment of the researcher is what guides the selection. Snowball sampling is a similar thing, except here you get your small initial sample by any method, and then using the information from the sample themselves, you choose further individuals. So you add more layers. It's good for social network research. So you interview somebody and then you ask, or you find out through them contacts to carry on your interviewing, and so on. Statistical analysis of data are much harder with these methods because you're not quite sure on the basis which basis people have been selected. Although people are developing ways of randomly selecting within networks. So saying, well, if let's say you start with one person, you get the list of their friends or their contacts, you randomly select some of those and so on. But it does get quite difficult. Before moving away from sampling onto measurement error, I'll just briefly mention some actual examples of research. Unfortunately, with real research, it gets quite complicated quite quickly. So we've gone through the basics. We'll just look at what's involved in a couple of real examples. Here's number one. This is by Dineen Bourne et al. In 2003. They're looking at blindness and visual impairment in Bangladeshi adults. So that's the message, the point of interest. Population is about 130 million people, of which 44.8 million. So here's the population they're interested in talking about. This many adults, they want to say something about how many of these are blind or visually impaired and what's caused that. Now, to talk about 44.8 million adults, the sample was 12,782. So the sample much smaller than the population. Yeah, but quite a big sample, which is the important thing. They used stratified cluster sampling, so they divided it in the country into 154 clusters. They knew that 79.9% of the population was known to be rural. They didn't quite go for proportional clustering. They adjusted weights using weights afterwards, but because most of the population was known to be rural, they put 104 clusters in the rural areas, 50% in the urban areas. So this is roughly 60-odd%. So it's slightly fewer than it should have been in rural areas, 50 in urban areas, and just adjusted afterwards. Then randomly chose those clusters with the probability of selection of each cluster proportional to size. The clusters were also stratified by administrative division to make sure they had the right number of clusters from each administrative division that would be proportional to the size of the division. Then within each of those clusters, then they did quota sampling, which is interesting. It wasn't a pure random sample, but they sort of argue it could be treated as such because of the characteristics of the people they ended up talking to. But they chose 100 people in each rural cluster and 50 in each urban cluster. Now here's the map. That's the map I had at the beginning of the lecture. There's all of Bangladesh. And the map shows whether the 154 clusters were. You can see these are the rural ones and these are the urban ones. So you can see there's there's Dhaka right there. Okay, so there's lots of urban clusters there and some of the other big cities around somewhere. She's gone down here and so on. And then the others get some provincial capitals, and then the others are these rural ones. So these are the findings. They found that there are 650,000 blind adults in Bangladesh, and of those, 74.2% of them, the blindness was associated with cataracts. 10 times as many, 6.65 million with low vision, and almost 80% caused by cataracts. So their conclusion is that operable cataracts are associated with the vast majority of low vision and blindness. And because these are operable, the policy message is a need for a national plan for eye care services, because these things could be addressed without an enormous amount of expense because they're operable, it's not too complex. And these are the kind of the level of need that's there for cataracts. So they've made their messages come out about 40 million adults from the 12,000 they've spoken to. Number two, we're looking at gender bias in Papua New Guinea. Gibson et al., 2004. Population of Papua New Guinea, 6.2 million, and a sample of 1,200 households. Again, stratified cluster sampling, 120 clusters. And the clusters were stratified using the census. So they made sure they had the right balance of rural-urban setting, right value, the balance of environmental conditions, altitude and rainfall, and agricultural development level. So it ranged from the sort of hand agriculture to irrigated to machinery and so on. And that household data, they weighted it by the difference between the 1990 census and the actual cluster size, because they found that the sample frame wasn't quite representative of the cluster size when they got on the ground, so they had to adjust because of that. And the difference between the households interviewed and the target. So in some clusters they didn't interview as many as they wished to interview. Households were missing, so they had to reweight the findings. And then their main finding was that boys over 7 years old receive a larger share of household resources than girls or younger boys. What they were actually measuring was what difference does it make to the consumption of discretionary goods by adults. So non-essentials, things like clothing, nice luxury clothing, especially alcohol, drinks, things like that. And they found that only when there's a boy of over 7 years old in the family is there a measurable decrease in the adult consumption of luxury goods like alcohol, which they interpreted as meaning that those are the only family, only with boys over 7 is there a measurable impact on family resources. Sampling example number 3 is pineapple growers in Ghana. Sample of 153 pineapple growers growing smallholders, so far smaller than these other examples. This is the sort of thing that can be done by a single research team or even the researcher. Again, first they selected 17 villages with different geographical characteristics. You can read the article, it doesn't say exactly how they selected these, whether it was random or purposeful. They've selected according to geographical characteristics, so they would claim that they're representative of the areas where pineapples grow. Now, villagers and chiefs gave this information, but about a third of farmers selling to exporters had contracts. So for every 3 farmers, one of them's got a contract, 2 hasn't. So that's how they stratified that. They made sure they interviewed about twice as many people without contracts as with. So it's a kind of a bit of a rough and ready form of stratification. And the main findings then were pineapple exporters a large number of pineapples are rejected by the exporters, which is consistent with theories of partial vertical integration. If you're interested in value chain theory and why don't the exporters just buy the fields up and grow it themselves, which would be vertical integration. And of course the argument is that then that means they have to take the risk themselves, whereas in this system, if the pineapples are not good enough for the exporters, they reject them, it's the farmer bears the loss. But there's partial vertical integration in that they still can have contracts with these people, but the contracts allow them to reject a large number of pineapples. So now we've talked about how we select the people or the individuals from whom we're going to try and get data. The final stage here of obtaining data is what questions do we ask? How do we take our measurements? So this is the topic of asking quantitative questions. So once you've selected the sample, how do you get your data from it as well? It's important to think carefully about how you ask quantitative questions. So we're going to look at some types of questions you might like to ask. Think about clarity. Think about how there can be bias in questions. And finally, we'll give some practical advice. You've got to think about what type of data you're trying to get. That can help guide you in terms of asking appropriate questions. And the working definition of quantitative data here is just any data that can be represented by numbers. And the responses can give you different types of quantitative data. For example, what is your occupation? You can view that as quantitative because even though they might say, I'm a farmer, I'm a fisherman, even though they're answering you in words, you can categorize their answers. And then you can count, well, how many people are fishermen, how many are weavers, how many are selling local alcohol, how many are farmers, how many pastoralists, so on. Another one is, well, how much do you agree with government policy using the following scale from 0 to 6, an attitude scale or an opinion scale. Another one is, how much maize did this field produce last year? Now these 3 kinds are called nominal and ordinal and scale data respectively. Now nominal is this kind of thing where it's just categories. And scale is the sort of thing you usually think of perhaps as quantitative data. Something you can measure. You can measure this physically as well as asking someone about it. This one that's kind of in the middle here, this is something that's got an order. So you can put it in order. Unlike this first one, you can't put this in order. If someone says I'm a fisherman, someone says I'm a farmer, someone says I'm a craftsman. How do you put those into order? They're just categories. These categories here, category of opinion scale, they have got some order in them. The difference between 0 to 1, 1 to 2, and 2 to 3 is not necessarily meaningful. And these nominal scale data, as in the last category here, this is the kind of data that we're used to thinking of as quantitative data. Where if someone produced 40 kilograms, then that's twice as much as somebody that produces 20 kilograms. And it's half as much as someone that produces 80 kilograms. Whereas here, someone that answers 3 on this scale, they don't necessarily feel half as keen about government policy as someone that answers 6. It's just less than 6. Right. Question clarity. Well, this is perhaps the most obvious one. If you don't ask clear questions, then the people you're talking to may not quite understand what you're looking for, and that can lead to measurement error. They may not give you the answer you're looking for. It's most likely going to be random misunderstanding. You don't know whether that's going to make them give you a higher or a lower value. But it could possibly be biased too. If people are tending to misunderstand you in one direction more than another direction, you could get bias. And hints to avoid this would be to avoid some of the things, like avoid double-barreled questions, like this one. Should traders be taxed and the proceeds used to support farmers' cooperatives, marketing cooperatives? You have to read it out properly. So, should traders be taxed? That's one question. And then the proceeds used to support farmers' marketing cooperatives. So there are almost 3 parts there, let alone double. Should they be taxed? Should the taxes be used to support farmers, and specifically farmers' marketing cooperatives? So the person that's answering has got to try and answer 2 or 3 questions at once. It would be better to break this up into 2 or 3 separate parts. Another thing that's not clear is when you put negatives in questions. Are you opposed to not charging for treatment? Research actually suggests that many people in an interview context will just kind of blank this not out and then answer the question, are you opposed to charging for treatment? Others might hear the not and they'll answer the other way, and your results will be almost meaningless if they have a mixture of those two. So be careful of negatives. Careful of ambiguity, especially things like usually, often, many, here. If you say to somebody, do you often sell this kind of crop here? Then how often, what does often mean? Does here mean in this village or in this country, or and how many times is often? So avoid this kind of term. Right, let's look at some sources of bias. Now, I emphasise that bias is worse than random error because whereas random errors will tend to sort of even out over time, bias is going to push you systematically in one direction or another. And particularly if you don't know that's happening, you can be very misled by your results. One very well-known one is leading questions. For example, how important is it to control the street vendors who cause littering and encourage crime? Here, the question is almost leading the person towards the assumption that they're assuming in their question that it's important, because they're asking, they're not saying is it important, they're saying how important is it? And they're also assuming that the street vendors are people who are causing littering and encouraging crime. So even though some respondents might challenge that and say, wait a minute, perhaps they're not causing littering, on balance it could be that you'll push people into agreeing with this. So you're pushing people in the direction of rating it as more important than they might otherwise do. And here's another one. Do you follow the advice of health experts and sleep under a treated mosquito net? Well, if you say no to that, then, well, you'll kind of almost suggest you're going against experts. So who are you? So this is using this language of experts, so telling you what the answer should be and then asking you. Emotive language. How important is it to improve the appalling condition of the village school? Again, emotive language, that often encourages inaccuracy, and if you say something's appalling, then the implication is that something should be done about it, so it's important. So people aren't going to give you perhaps their reasons, judgments about it. They're going to give you an emotional reaction, which will overstate what they feel should be done. Similarly, socially desirable responses. Should crop pickers receive a fair wage or a market wage? If you're asking that perhaps to a plantation owner or someone that pays people to work on their farm picking their crops, it could be that the truth is that they'll pay them be closer pretty much to the market wage, what they can get away with. And not, it has to be too harsh, but perhaps a market wage, a fair market wage, but it wouldn't necessarily be a fair wage. They'd be influenced largely by how little they can pay them. But when someone comes along with a clipboard and asks them that, particularly in this way, should they receive a fair wage, the person might be more likely to say a fair wage than telling the truth, which is this, because it's more socially desirable. Another category is response sets, particularly when you get quite long questionnaires. If you have a long page where it says indicate how much you agree with each of the following statements using the scale, and you have a whole page of things with 0 to 6 after them, from 0 completely disagree to 6 completely agree. Research again shows that a lot of people get tired and they just once they've ticked the first few as 3 or 4s, they just go the way down the list, ticking 3 or 4, not really looking at what each question is supposed to mean. Acquiescence response, this means that when there's a tendency to select things that you say agree more than disagree. So if you're asking people something, they'll try and agree with what they think you want to hear, or as of either wanting to socially go along with what you're saying, or because they're getting tired of the interview, they'll just acquiesce, which means go along with what you're suggesting. So that can be a problem. You get a bias towards positive answers, even when that's not what they really think. Third one, another very important one, is framing. This is where you give information which sort of sets the context or sets the way that people are thinking about things. So, did the Agricultural Extension Service work well? That's one way of asking something. Or you could answer the question, you could put the question like this. You could say, over 90% of village maize survived the disease. Did the Agricultural Extension Service work well? Another one would be saying, nearly 10% of village maize was ruined by disease. Did the Agricultural Extension Service work well? You might like to think to yourself, in these three contexts, which way would people tend to answer, or would they answer always the same? Because all three of these could be asked in the same context. Because of course these two things are consistent. So depending on your choice of which way you ask it, would you get the same answer from people? Or, as I think, that some of these might push people in a certain direction and some will push them in another direction. Another thing, in ordering effects, after you had a whole sequence of questions about logging and firewood scarcity, then you ask them, can you list the most pressing issues facing their community? And it could be that in these most pressing issues, they'll list, oh yes, firewood scarcity and loss of forests. But if you hadn't already had this sequence of questions about logging and firewood scarcity, that wouldn't have been in their minds. And they might put other things higher up the list. So the ordering effect can trigger that memory and make that something that they think is important to mention, which they wouldn't have otherwise. Related to memory effects, fourth thing, fairly obvious really, minor events in the past, small things you're asking about, how many times did you travel to the market 2 years ago? They just can't remember. Can you remember how many times you went on a local trip 2 or 3 years ago? You can't do it. So that makes it seem as though you go more frequently recently. Telescoping is when past events seem more recent than in reality. So if you say, how often did you travel to the cities? That's a fairly major journey in the last 6 months. Trips that you actually made a year or 2 years ago seems more recent to you. So you say, oh, I've been to the city 4 or 5 times this year, where in actual fact some of those 4 or 5 times were well before the 6 months. And that's called telescoping. And finally then, some of the many tips you can find in the literature on asking questions. First and foremost, pre-test, which means try it out. First of all, just try it out with your mum and your friends and your supervisor. Then try and go on an initial trip to where you're going to do the research and try out with a few people in the field, maybe your research assistant and some local people, just to see if the question is being understood in the sort of way you expect it to be. To reduce ambiguities, there's things that people might not get. You could try picture cards. Pictures with the process or the situation or the thing that you've got in mind if it might be ambiguous. And give definitions of terms that might be ambiguous. Avoiding unnecessary detail, that can save time and make people feel less intruded upon. For example, giving incomes in ranges rather than asking someone to state their exact income. Similarly for age, say, okay, what's your age to the nearest 5 years? Or what's your income? And show them a piece of paper with bands on. Avoiding acquiescence, I think this is quite a clever idea. Instead of saying, do you agree that so-and-so and so-and-so, you could, if you give an agree option, you should have a disagree option as well. So say, do you agree with this? Do you disagree with this? And you state the thing in neutral terms. So it's not what the interviewer thinks. It's saying, do you agree that agricultural policy needs to emphasise new varieties? Or do you disagree that agricultural extension needs to emphasise new varieties? So they're both okay. They're more balanced. Sensitive matters. If you have to deal with sensitive things that someone might not necessarily want to talk to you about, research shows that if you put the possible responses on a card and show it to them and say, well, have a look at this card, it shows some possible ways that you might deal with a situation that arises. Could you give me the number of the response that most closely matches what you would do or you would think? So all they've got to do to you is read out a number without actually talking about the thing if it's a sensitive issue for them to discuss. Some more practical tips. Reuse questions from previous studies. I'm not ashamed to say that I've certainly done that. It's not unethical, unless the questionnaire says these are copyright, which I've never actually seen. Particularly if you get them from studies that you admire or that from big organisations, United Nations or anthropological societies or similar organisations. They've already been well thought through. They've been road tested many times before, so all the little wrinkles that can throw people have been worked out, and it helps make your findings comparable with other work. Certainly, I saw the National Budget Survey in Tanzania before I did my own research in Tanzania, and I deliberately modelled some of my basic questions on demographics closely on what they had, so that I could then compare my results, and also to make sure I didn't word it in stupid ways. Finally, online tips on question design. There are a number of these, a number of complete questionnaires you can find online. This is a particularly great one. The research method is knowledge-based, run by someone called Bill Trockham, who's got a lot of detailed advice. And there'll be a link to that in your outline pack. So, conclusions. When we're trying to obtain quantitative data, it's hard to sum up so much detail, but what can we talk about? Well, we have to identify population and sample. It needs to be crystal clear. What's the thing you're trying to talk about? That's the population. What's the thing you're going to get data on? That's your sample. Then you need to make a decision, well, are you going to carry out a census, talk to everybody, or just select a sample? You have to be clear about the distinction between measurement and sampling errors as two sources of errors. And then also the distinction between these kind of sources of errors, what kind of errors are they going to cause you? Random errors or systematic errors, which are more serious, and it's systematic errors that lead you to bias. Don't forget that your replicability and validity depend upon the sampling approach, both in terms of how good your results are themselves and in the ability of other people to have faith in your results and perhaps reproduce the work themselves. Then there's specific techniques, random, stratified, cluster sampling, and the other less used variations like purposeful and quota and so on. Understand when these are and how they can be used. And even then, when you've got your sample, even though you selected a nice representative sample, you still need to avoid measurement error when asking your questions. Okay, well that's the conclusion of this lecture on obtaining quantitative data. Thank you for listening, and I'll leave you with the slide of references. Thank you.